Good morning. This is a great venue. I'm so excited to be in like tight-knit area. This like just feels so like it's like community together. It's exciting. Also really excited about the photo booth. That was really cool. It's great to be able to see it like NURBS being used out in the wild, and I got a chance to use it. I'm sure between talks we'll see more photographs. But so I'm here to be able to talk about adopting NURBS for use with IoT. And so a long time ago, back before my involvement with working with Frank and progressing NURBS, I had this goal. My goal was I wanted to be able to start my motorcycle using my phone. This was before I knew anything about the life of hardware and what the problems would be with the complications would be coming along with that. And so spoiler alert, I did it. So here's a picture of the project in the end. And what I learned through this experience, this was originally done using Arduinos and microcontrollers. And what I learned through this experience was that that hardware it can be hard. It's that's surprising, I know. And at the time, I was doing software development, and from the web development, we've seen all these great frameworks and everything to be able to make our lives easier for developers to be able to build software applications. But there wasn't a lot out there. It was just starting to sort of come around that friendly libraries and frameworks to be able to help build hardware devices. And so through this project, when we get involved in these things, we look at these problems that we have, right? I need to start a motorcycle from a phone. That's a really cool problem. And I'm like, you're just laser focused on that one thing. You're like, all right, I'm going to start this thing. It's going to be called Motometrics, right? And I'm going to start my motorcycle from my phone. I'm like, that's the thing that I'm focused on the most. I'm going to go and do it. And then all of a sudden, I'm like staring at wiring diagrams for months. Just to find the integration points that I needed to sort of get into the actual motorcycle. Fun fact, starting a motorcycle from a phone is not that much different from learning how to hotwire motorcycles and cars. So after staring at this for months, I finally found all the right stuff and I got it put together and I felt great. And I'm like, you know what, we're gonna do this. I modeled my problem. I got my ECU. I need to connect that up to the ignition, and then what's that up there? The network? Networking was something that's solved before, right? Everything's good. I'm gonna get a website together. I'm gonna put this thing out in the market. I'm like, okay, what do I have left to be able to work on here? Start my motorcycle from my phone? That's done. But what about all the rest of the stuff? Oh, wait, yeah, I gotta get it connected to the cell phone networks. I gotta be able to do firmware updates, and I gotta put a web server together and security. But those all seem like problems that are like easy and solvable, right? Well, just you wait and think about those for a second, because on a desktop computer, that's something that we take for granted. But on tiny little microsystems, we're left with these problems. We're like, how do I take this thing and how do I ship it into production in a way that I can reasonably connect it, or make sure that that cell phone connection stays active, or that the firmware update mechanism will always be available. It's really comes down to then, like, how do we take these really cool, interesting problems that we care about the most and get rid of all of the stuff that we don't care about and package that up in a way that we can just do what we want, and how do we put that in and make sure that it continues to run? And so the real question is, how do we build maintainable embedded systems, right? And that's what we're trying to be able to solve with NURBS project. So NURBS project, what is it? Well, the NURBS runtime, which is what you're going to package your code into production, is essentially the Erlang VM monitoring your application and built on top of the Linux kernel. The reason that we try to be able to boot you right into Erlang as quick as possible and consider that to be the place where you want to exist with your operating system is because inside of that, using Erlang as your OS, as your operating system, has a lot of power and benefits. I mean, we get a lot from Erlang when we run our applications in them today, and being able to have that be the top of the world really can be powerful. And so what is, with the NURBS runtime, we have the operating system level at the bottom, and then what you care about most, which is the application domain up here at the top. And inside of this runtime, you can fill the application domain with whatever you'd like. When it comes to processes that are running on your application, we don't mind if they're written in Elixir. I mean, it would be nice. We're all here for an Elixir conference. But we also don't mind if it's running in C or Python. We also don't mind if you want to be able to monitor other things like microcontrollers. Really, it's whatever you want to fill this with, you can. All right. So how does this benefit us? Well, see, the NURBS runtime, because it's built on Erlang, is resilient. The resiliency comes in process monitoring, because if something were to crash, like our process that monitors the network or connectivity, then Erlang will just restart it. And that kind of resilience is important when we ship embedded systems. Because when these things are in the field, they're usually put into places that aren't very accessible. And you don't want to have to drive all the way out to wherever you installed these things all the time to troubleshoot them. You want to be able to do this stuff remotely and make sure that they continue to run. It's not like you can just call up the data center and be like, hey, can you reboot this device, this web server? The problem space is a little bit different. Furthermore, we have resiliency in the way that we lay out our actual device partition structure. See, when we ship these devices, we actually ship them with basically 2 firmware slots. And the idea is that when you write firmware to the device, you're going to write it into the first slot. And the second slot's going to be inactive. And then when a firmware update comes in, you'll stream that into the second one, and then try to see if you can boot off of it and validate it. And if everything's good, then success. Let's make that the active one. In the web language realm, this is usually known as something called blue-green deployments. And we build this into our devices so that you always have a known good working copy that you can sort of fail back to. And this is another way that we can prevent ourselves from getting into the cases where the device becomes useless, like a brick. Furthermore, we also have this piece at the bottom that we're labeling application data. Because these partitions are mounted read-only, the application data location at the bottom here is a place that's read-write, where you can actually store like your ongoing state, right? Like if you have some sort of data that you need to persist throughout reboots. Also, the NURBS runtime, we strive to be able to do things in a reproducible fashion. As mentioned, reproducibility is not just for code compilation, but reproducibility I see as far as being able to make sure that when you boot the system, it boots the same way every time. So read-only file systems are important to be able to prevent mutations and also to be able to prevent data corruption. That means that when you turn the machine on, every single time it boots, it's pretty much going to boot up the same way. And so you can use that as an advantage point towards making sure that for debugging and also for reproducing these problems locally. And the immutability. I mean, we all know and love immutability aspects of Elixir and Erlang from a data standpoint. And from the read-only portion, the immutability of the runtime system is really important because that also allows us to be able to create these reproducible systems. And then we're also working towards the compilation time reproducibility. And this is tedious work. People, when you compile programs, sometimes applications love to be able to tuck in things like timestamps. The user who actually compiled that will get stuffed into some metadata on the output. And those things might change. So that way when you bring up your source code today and compile it, we want to make sure that when you bring it up a month from now and compile it, it's going to produce the same output. And those complications prevent us from being able to get there. But slowly but surely, we're trying to be able to work from the bottom layers up to be able to ensure that we can perform as close to as possible these reproducible builds. But it's ongoing effort and work. And then finally, NURBS runtime systems are reasonable. And that's because primarily we use a build-up approach. And what this means is instead of shipping a device using a large desktop scale operating system, like if you think of like desktop Linux or Mac OS or even Windows or like a full desktop operating system, those things weigh like hundreds of megabytes to gigabytes these days. And that's basically because they contain a lot of stuff, a lot of drivers, a lot of support, a lot of programs and applications to make sure that the things that you plug into those devices are actually going to like work. When you go out and buy a new peripheral, you plug it in and it's just going to show up and work. But the reality is with these embedded systems, these are geared towards being single-purpose computers. And so when you ship these into production, you should know what like support for device drivers you need out of the gate, like from the start. And so therefore, instead of trying to be able to take the sort of like security tear-down approach, of IT these days, where you're like, okay, I got this desktop operating system. I'm going to turn off. I'm going to prevent the user from being able to do this and this, and I'm going to prevent them from doing this. That's good because it helps you protect the system from the things you know, but there's all these other things that you don't know that are also things that you need to protect against. It's the stuff that you don't know that you don't know. So the build-up approach is a lot better because in that case you can you are only opting to compile in what you need, and that produces really, really small and lean systems. If we were to take a NURBS system on a Raspberry Pi and build it out of the box, we can get pretty much around and under 30 megabytes, and that's the full OS and everything to be able to boot it up and run it. And still, there's some work there that we can do to be able to trim that down, because we, in those basic systems, are also including things that you may not need to be able to run your application. But it's a good starting point. In addition, that's the minimal output that makes them reasonable. That means that we can actually understand what we're creating. It prevents us from being able to produce these systems that have security vulnerabilities that we don't know about, because we're only putting in the stuff that we need, and therefore when a security patch comes out, we can ensure that we're patching all of the things that we care about and that are included in our systems. So where can we run NURBS? Well, NURBS can be deployed virtually anywhere embedded Linux is supported. And so some people think that with NURBS, it'll only run on like Raspberry Pis or this and that. But the reality is that if it supports embedded Linux, odds are good that we can make it work on NURBS, to run NURBS. So who's using NURBS? Here's a list of some companies that are using it currently today. It's a little tough to, we try to be able to push this a little, to shake out a lot more companies that are using it. If you're using NURBS in production, then reach out to us and you'd like to be able to promote your use of it. We'd love to be able to hear about it. It's just a little different when it comes to hardware projects. People like to keep them secretive, it seems, more so than the software-based projects, so it's interesting. And so the real question then is, well, those companies are using NURBS, and that's great, but how do I start using NURBS at my company? And that's really what we're trying to be able to talk about, some of the questions around adoption and how do we start using it in our organizations. And so the first thing you need to do is choose what platform you want to build on top of. And this is all about these NURBS, the NURBS systems. A platform would be what device you want to start building on top of. As I mentioned before, there's Raspberry Pis and stuff, but the real thing is the considerations that you have to take when it comes to choosing how to get started. Everybody says do I just buy a Raspberry Pi, or do I buy like this BeagleBone thing? And the reality is well, it depends on what you're trying to do. First off, the first question you have to ask yourself is how many of these am I going to produce? Is the project going to be a low volume project or a high volume project? Do I need to make one of them or 1,000 of them? Because that's really going to help you drive things when it comes to what you're going to purchase to be able to start building on top of. Also, if you just need to be able to create a couple, well, if it's just a prototype, then you can get away with buying some prototyping hardware, putting it together and making your proof of concept. And then maybe you can move into a domain where you can say, okay, now I need to produce 1,000 of them. And switching platforms is actually not too terribly difficult in NURBS. We do support the ability to target multiple platforms, and you can just kind of easily switch between them. And this is beneficial for cases where in consideration you go, well, I don't quite have my custom board that I need, that I'm dreaming about making to make thousands of these things yet, but I do have these prototyping pieces of hardware that I can put together and build with for now. And so the idea then is like you can get started building today using prototyping stuff and then just switch targets later and then work out the details and massage things into place. Also, questions that you have to ask is, in the operating environment, like where you're going to install these things. Is it going to be really hot or humid or cold? And is the hardware that you're going to put in that environment going to support that? Or is it going to break down? And there's always budget concerns. You know, how much money do you have to be able to put at the problem? Creating custom hardware can get kind of pricey and expensive. And really, if your volume is low, then you don't necessarily need to go down this custom hardware route. So you can sort of play with the levers a little bit to make sure that you can satisfy the budget constraints and the volume constraints at the same time. And then the bottom ones here are really important. A main primary driver I always find when trying to be able to determine which platform I want to build on top of is usually I/O. It's a big concern because let's say you're putting a project together that has a whole bunch of these like sensors, and these sensors connect on using a protocol that requires a high number of I/O or pins to be available. And not every board is going to give you all of the support that you need to connect all of those sensors. The idea there is then, that's going to drive your decision to say, well, this board's not going to work because it only has maybe 2 or 3 of these buses, and I need like 10 or 8 or something. Then I got to look at these other ones to be able to see if I can get enough wires, enough pins, enough I/O from there. Also then, dictating factors like third-party software requirements. You might be working with a vendor, and that vendor might only provide you with a precompiled binary of their software so that you can interact with their proprietary piece of hardware, let's say. And that precompiled piece of software might be written in an architecture like x86 or ARM, and that's going to drive you towards making decisions on what architecture the platform should be running the chip. And then also regulatory concerns. This is something that a lot of people don't really consider out of the gate, is that let's say your device, you want it to connect to like a cellular network or something, and then you have the idea that you're going to end up putting like a custom board together. Well, if you put the radio emitting components directly onto the boards themselves, then you have to go through FCC verification or ISO verification if you're like doing these in Europe, or if you're putting cellular stuff down, then you might have to actually validate that your board complies with the cellular carriers. And while this isn't terribly difficult, it's a high level of nuisance in a way, I guess. There's just a lot of overhead involved in having to be able to jump through the hoops and getting to a testing facility and making sure everything passes. And it's just extra work that you could be using to focus on your actual project. So usually these considerations drive a lot of this stuff, but really at the high level, it's like, well, you're going to produce a bunch or a few. And so getting started, we say, if you're doing low volume stuff or prototyping stuff, some easy options to be able to choose would be like Raspberry Pi, or this one here. This is a Pocket Beagle. The size of that's about like a quarter. Like if you put, the board top to bottom next to it, it would be like, actually, maybe a little bit bigger. But it's about the size of like a stick of gum or less. And so these are really great to be able to get up and started with quickly. And on the right over there, we have a part that's called an Octavo chip, and the reason that that's under a higher volume column is just because, like in low volume, getting away with these devices that you can just purchase like a couple of them off the shelf is great. But when you go to the higher volume ones, it's going to be a little bit more difficult to acquire these in like quantity. And so therefore, you're going to start considering like, I need to build custom boards now, and the Octavo part there is the same sort of system module that's on the BeagleBone Pocket Beagle, and it's really convenient to be able to use because you can basically lay that whole thing down on a device, and it handles a lot of the work for you. It's got the processor, there's the memory in there, power management, and all kinds of stuff inside that one chip. And then furthermore, the BeagleBone boards themselves are open sourced hardware. And so it makes it really nice to move between prototype and production because you can use the same architecture and the same platform, but when it comes time to manufacturing, you can actually remanufacture the layouts of the boards from BeagleBone the way that you like, so that you can produce your own custom stuff. And then that's going to save a lot of sort of time and money when it comes to the hardware design aspects of this. Now, the higher volume stuff, if you're interested in doing higher volume custom boards, and that seems a little scary for your company, feel free to reach out to us. We have a lot of people in the community that we're aware of for partnerships with manufacturing vendors that we can help promote to solve the problems for you. And so from the basic point of view, well, what do we support out of the box like today? What can I just grab a board, plug in, and get running? And so a few slides ago we said NURBS can be deployed virtually anywhere embedded Linux is supported. And while that's true, we as the developers of the NURBS project maintain a handful of systems to be able to help get people up and running quickly. And these systems are not, like, as stated, the only ones that you can use. It's just that these are the only ones that we're willing to do a lot of work to maintain over time. But as more prototyping hardware comes available, usually ones that are popular in the community, those are the ones that we end up finding ourselves producing supported systems for. So from the top, as a joke, yes, every Raspberry Pi made ever made. That includes like compute modules, and there's a bunch of other stuff there, Raspberry Pi 2 and the Zeros. The Pi 4s just recently came out, and while we do have support to run NURBS on the Pi 4s, there are some outstanding issues that we're just working on currently. And also, as we spoke from the previous one, the BeagleBone series, there's a bunch of different kinds of BeagleBones depending on form factor and also I/O or different considerations that you need. And x86, well, we do have a basic x86 system that you can get started with, and this is basically to run it on like desktop hardware. We have at our company we have a couple of all-in-one machines that we actually run this on. And it's pretty silly. You get them with like a terabyte hard drive, and you're only using like 100 megabytes of it. And then at the bottom, yeah, that's the virtually anywhere embedded Linux is supported. Custom systems are totally supported to be able to build your own. There's a bunch out there in the community that people have started taking off with. I know that there's a group that created some for the Orange Pi series, and there's also a whole bunch of other ones. And that's handled through the lower level tool that we depend on called BuildRoot. And so the easiest thing is if you're going to try to port to a new board, check to see if it has if BuildRoot has a profile to build for that board. Because if they do, it's your hurdle towards getting NURBS to run on it is a lot lower. So. All right, so now that we know what platform we're going to choose in our case, how do we start building a development team? Because that's the next question. We know what to build on, but how do I get developers to be able to build NURBS things? Well, you're in luck. Because NURBS is written in Elixir, if you're doing new projects, just hire a bunch of Elixir developers. Yeah. So since you can write a lot of your logic in Elixir, if you're doing new projects and that's a language that you want to be able to stick with, higher level languages are great because you can move quickly. And one of the powerful aspects of NURBS is that it makes connecting to the web and interacting with the network a lot easier than you would on Arduinos or lower level microcontrollers. Like getting TCP stacks to run on those things can be complicated. And so doing it on these more powerful systems using NURBS makes that a lot easier. And furthermore, hiring Elixir developers to be able to do your embedded systems work, you can also use those same Elixir developers to be able to do web programming work. And I quote embedded system work because this is kind of a way to be able to trick Elixir developers into working on embedded systems without knowing it, because you can separate a lot of the concerns of your business logic into just OTP applications that can get tested locally on your hardware instead of having to do all of the work on locally on your laptop instead of having to do all of the work on your hardware platform. Now, new projects are great because greenfield is always fun, and because we can dream about anything. But the reality of life is that there's existing projects we have to deal with, and this might be like what your development team would look like, in that you have a big chunk of C that handles all your business logic now and device drivers. And in this case, it might be microcontrollers that you're using, or it might be microprocessors that you're running on. But really, if you're to adopt using NURBS to satisfy the IoT platform requirements for your project, then you can sort of scale your team a little bit so that you only have a few Elixir developers that can do all the integration work, where you can do, you'll write all of your device initialization logic using Elixir, and handling all your process supervision. And the benefits here is that just by taking your existing application and putting it inside of a NURBS runtime, the process supervision aspect now gives you the ability of monitoring the processes, the C applications and other userland applications that your device depends on to ensure that, that they remain running. And also it then allows the web communication layer to be done a lot quicker and easier. And on either of these paths, you're going to find yourself in situations eventually where you're going to need to be able to satisfy some obscure sort of programming, right? You're going to come across a device or something that requires maybe modifications to Linux or some additional kernel configurations, but that's the scary land for a lot of the higher level language developers, but the nice thing is there that you can satisfy those problems usually just using consultants. There's since NURBS is built on top of embedded Linux, finding embedded Linux developers actually they're plentiful, and so asking them to be able to produce some output that you need, some drivers or some little Linux modifications. Can be done on a consultant basis and then integrated into your project so that you and your team can stay on the happy path and the high level here, and then you can just sort of gather some of the requirements from consultants' work. And that way you can scale your team more appropriately for the long term. All right, so now we have our development team. The reality also is that we're going to have to deal with interfacing with microcontrollers at some point. Because let's say in the considerations here, our application has some hard real-time tasks that we need to perform. Well, using Linux and Erlang doesn't really give us the ability of running hard real-time constraints inside the VM. There's some research that's happening to be able to try to see if we can progress this further, and there's other projects in the community that also are working on trying to be able to see if we can get there. But in the meantime, the easiest thing to do in this case would be just to offload this processing to the microcontroller and connect and communicate with it and manage the microcontroller. Another consideration too would be, let's say you have some analog inputs that you need to deal with. Well, microcontrollers make that pretty easy. So you might offload that. And also microcontrollers are good for power management strategies, that they can run at really low power for the tasks that you need to get done. So in here it's like, well, the idea is like, we can use NURBS to be able to do all of the higher level things that connect to the network, but we can offload all of the lower level things to microcontrollers because they're good at that stuff. And it's not a scary place to be able to join these two together. One of the companies that uses NURBS from a previous slide as an example is FarmBot, and they use a Raspberry Pi and basically a microcontroller Arduino style device similarly to this layout, where we can communicate back and forth between the microprocessor, the Raspberry Pi, and the microcontroller using like UART, so we can get data back and forth between these devices locally on the board. And then because we can wrap these in supervision, we can say like, okay, if something goes wrong with the microcontroller code, like something crashes over there, we can embrace it into our supervisors by tying into reset lines. And so you can imagine in this case then, you're communicating back and forth with your microcontroller. The microcontroller gets into this weird state, let's say, or it just stops responding. Then your microprocessor supervising that microcontroller can notice that the communication dropped and trigger the reset line to be able to make sure that you can let it crash and come back up. This is a good strategy then to remain in the runtime. Also, in the benefits of NURBS, we get the ability to do firmware updates remotely. So we can provide the firmware that runs on the microcontroller as part of the firmware package that gets deployed onto our NURBS system. So the strategy here usually is that when you receive a firmware update on your NURBS device and it loads for the first time, it'll go, oh, I've got these microcontrollers and packaged in my firmware is this new firmware. Let me try to send it across the wire and burn that new firmware to the microcontroller. So you update the NURBS device, and then the NURBS device distributes the updates to all of the connected components. All right, so now also the fun bits. We've got a little bit of data that we're going to want to be able to put out to a display because we want to make sure that this device continues to run. So, we want to be able to see it visually, or you might have additional requirements with your device that you need to be able to let a user interact with it or see some feedback. So how do we render to an interface? And there's a couple options here. From the start, well, all these options, I should say, depend on the kind of data you want to render, maybe the display that you have available, or even the kind of developers that you have on staff. Up front, there's this first option, which is Schneck. And so Schneck is a framework for Elixir that lets you build user interfaces through OpenGL. And it has these primitives like, buttons, or primitives like rectangles and some text and some click-through items like drop-downs and stuff like that. So you can build some pretty interesting user interfaces using the Schneck. And it's really lightweight in this case because you're essentially just describing your user interface using data structures that can get rendered using OpenGL directly to the interface. Now, the downfall here is that obviously you have to write all your user interfaces in Schneck, and you might have a bunch of web developers on hand. So there's another way to be able to do that one. But Schneck does give you some powerful uses. Like, for example, here's a project that one of the developers presented, I believe at ElixirConf, that was a Schneck application on their laptop here. Interacting with a racing game, and so they basically just streamed the data across and then just had an external display that they could use to be able to show their game data. Here's a snapshot of the training course that we've taught this year for NURBS, where it was called NURBS Team. It's a take on Space Team. And these devices are all wireless connected. The USB cables there are just for power, but they're all Wi-Fi connected to a central server that they're running this game on. And we're actually using Schneck to be able to render some of the text to the display and the progress bars. But as I mentioned, your team might consist of some web developers, and that's not a bad thing. Your device can actually render web application, web pages directly to the display. And so this is probably not the best example of this, which is just like rendering some squares of data over there. But essentially, this is a Raspberry Pi 7-inch display in one of our warehouses that's using web technology to render to the display. We use these a lot to be able to let our web development team participate in creating user interfaces for the embedded arm of our organization, which is great because, like I said, you can trick Elixir developers into becoming embedded developers. The kiosk systems that we have are currently for Raspberry Pi 3 and x86. We're working on Pi 4, but it's new, and like I said, there's some stuff that we're ironing out there. And then another option too is maybe you don't even need a display. Maybe you just need a way for people to be able to connect to these devices and get some data. A common use is to be able to just spin up like a Phoenix server in the background and then just have it so that when people connect to your device, they can just access a known web location. And then a configuration page will display in their browser. I mean, this is common that we're all familiar with usually for like setting up wireless routers or anything like that. And there's also, I should mention, a project, our next version of our networking stack that we're working on. It's called the VintageNet. There's a VintageNet wizard that you can actually pre-package into your devices. And the idea with the VintageNet wizard is that it's a really easy utility that when you start your application for the first time, if Wi-Fi is not configured, then you can start this wizard, which will bring up a Phoenix server, which will then let you, and it'll also take the Wi-Fi chip that's in it and broadcast an access point. And so you can look for a known access point, connect to it, and then go to the known web page and configure it to connect to your Wi-Fi network. and then when it sets it up, and it'll then go into like the run mode where now Wi-Fi is configured. It'll save those settings, and when it reboots, it won't go into configuration mode anymore. And there's some fallback cases you can use there to make sure, like, well, if the power, if things go really wrong and the device completely like factory resets, that it can fall back into that configuration mode. It's another case that some of us are familiar with. All right, so now how do we connect this up to the cloud? Because we're like building ourselves up here. We got all our stuff layered up on our device. And how do we get this data out to the cloud? And the first thing before we connect anything to the cloud is to talk about security. And so this right here is a crypto authentication chip. This is an AT-ECC 608A. It's a it's available in teeny tiny little packages. It's very easy to plop down on your board if you're building a custom board. It's only a few cents to be able to throw it on there, and it makes all of the difference in the world when connecting securely to these devices. The point of this chip is it contains public-private key pairs for your credentials for the device to connect to remote servers. Like so, consider SSL certificates, right? We know when configuring SSL in Elixir that we have to provide the private key and the public certificate, and the private key is something that we always want to keep private because that's important. In this case, when you configure a crypto authentication chip for the first time, you basically tell the chip, hey, I want you to create a new public-private key pair, and it produces that on itself and then only shares the public one with you. The private key never leaves the chip. And they do a lot of work to be able to make sure that from a hardware perspective, this remains consistent. That you can't like pop the cap off the chip and like do some really elite hacking stuff to be able to like spy on the actual like set bits and figure it out and reverse engineer it. Like they put a lot of time and effort into these things. So it's really important to use these devices. And because it's so important, Frank has done a lot of work over the last year to be able to make it even easier for us to be able to prototype with these by creating by putting this chip onto a easy-to-use board called NURBS key. And in addition to being able to store the private information, you can actually use NURBS, this chip to be able to store other, there's like slots in it, so you can store additional certificates, and you can also store additional like settings into it. You can just put a bunch of like secure data into it. And so NURBS key was produced to be able to use for Raspberry Pis directly. You can see here, this is a Pi 0. It's soldered onto the back of it. It connects via the I2C pins and lifts the power and ground off of that. But you can really just use it on its own and hook up some wires to it, or even just plop it down onto a prototyping board and go from there. So NURBS keys are available on the Tindy site that we have. You can pick them up in quantities of one or more, but I would highly recommend picking them up in quantities of at least 2 or more. Because the thing about these chips is that they're one-time programmable, and so if you screw up the first time, you just get another one. Yeah. So that's another security feature of these. You tell these chips generate a private key on it, and it's like, okay, I did it, and that's the private key that I have for life. So it's another way of securing the information. Yeah. So check this out. I believe that there's some price breaks for quantity here, and if you need really high amounts, then reach out to us directly, and we can help you with that. Okay, so these crypto chips, what do they help us do? Well, connecting to the cloud, the first thing we're going to want to make sure is that we can receive firmware updates. And over the last year or so, we've been working on a firmware update server we call NURBS Hub. And what NURBS Hub is it's a hosted application that manages your devices and firmware and connects your devices using Phoenix channels to be able to manage the firmware that's running on them. This is really cool because you can sort of group devices into like, you can tag devices and say like, okay, this is a handful of QA devices and this is a handful of production ones, and over here are my dev devices, and that way then you can target running specific firmware to each group. You can also embed this into your continuous integration pipelines so that you can say, okay, anytime a new piece of code is built, I want to push firmware to NURBS Hub and deploy it directly to a bunch of QA devices or dev to be able to make sure that this passes validation. Another great feature of NURBS Hub is that we have remote console support. This is something that you have to opt your device into, so it's a setting you have to turn on. It's not on by default. But this is great because it allows you to debug sort of information remotely. If you wanted to be able to get at an IEX shell, you can do it directly from the web interface. And because, with NURBS Hub and NURBS, because we believe that everything should be 100% open source and available, you can run one of two ways, hosted at nurbs-hub.org, where we have trial accounts available, and that's all managed by the NURBS team. It's scalable, it's secured, and also you can run it privately if you'd like, because we know that companies often find that firmware update servers are a very private thing to them, and they want to be able to have full control over it. And so in that case, you can run it at your domain, and there's unlimited account space, and it's managed all by you, and that's available to deploy today. But we're also working on making the documentation a little bit better to be able to help people who are building private instances to get them out there more easily. If you're interested in running your own private server, or you're interested in the hosted version, you can reach out to us and get more information about that, or we can also help to guide you one way or another. And so that's how we can connect to our firmware update servers, but we're also going to want to do some additional business logic. Well, in the case of the company that we're envisioning here for the Motometrics device, I'm going to want to be able to connect to a custom web application, because I'm going to have accounts and my users are going to be wanting to go somewhere to view statistics, right? So communicating with web servers like Phoenix or others is pretty easy. We can use the same crypto authentication chip and its credentials to authenticate us to web servers. We can do this by a number of ways. Well, your signing certificate you can just include on your server, and that'll allow that connection. Or there's also other features for NURBS Hub that you can use to be able to do what we're calling delegated auth, that when your device connects to Phoenix or other applications, you can pass the SSL certificate that was given to you from the device along to NURBS Hub, and NURBS Hub will tell you whether or not that device is trusted by your organization. And then you can decide whether or not you want to let it in from there. And you can do this using Phoenix channels, using the Phoenix client library, or you can connect over HTTP using Mojito or Mint are great choices, and more too. I mean, anything that's going to let you do HTTP calls. If you are of the AWS type, connecting to AWS IoT is actually pretty easy as well. And this is something that a lot of us internally do for our organizations. It makes trafficking data securely to other services, like instances that you might have running on EC2 or ECS, or you want to be able to persist the data into a pipeline. Amazon makes it easy once you get it inside of their infrastructure to be able to traffic data wherever you want it to go. Connecting we do to Amazon IoT, and there's also some documentation that we're making better on this as we go along, but you can do streaming always open connections using MQTT, using the Tortoise library, or you can connect using HTTP, once again using Mojito or Mint, and that would be more for a strategy where there's only a little bit of data that you need to send periodically. So that's how we can use NURBS project to be able to solve a lot of these business case problems that we have. So here we are, we got our motorcycle project. We already started it from our phone, and now we've got our cellular networking set up and our firmware update servers. We can connect to web servers, and we got security taken care of. We can ship this project, right? Woo! All right. So I wanna be able to touch on one thing here, and this is a quote that I really enjoy. It's when you do things right, people won't be sure you've done anything at all. And so this one, it really resonates with me in multiple ways. I believe that from a hardware perspective, this makes a lot of sense. The devices that we interact with on a day-to-day basis, if that device is operating normal, like if it's doing its job right, it should feel almost transparent, right? Like we shouldn't actually feel like we're doing anything different. Like it should just sort of naturally fall into the routine of our life style. But the problem is that this world is full of unexpected input. There's all kinds of things around us that we don't expect or know or consider to happen. I mean, there's use cases in your applications that you never designed for originally, but your users are going to find near immediately. This is a funny one from a while back when we did a training class for kiosks, where the very first thing somebody did when they booted their kiosk was tried to put emojis on the screen, and then they're like, emoji doesn't work, open an issue. So it's things like these, this unexpected input that we get to that really prevents these systems in the wild from operating properly. But the reality is that Erlang is a tool that was designed to be able to help us create like structure, to be able to handle unexpected input. Erlang supervision, it helps us solve these problems. It makes it so that we have strategies in place to be able to create these systems that will handle this. And that means that it allows us to say that NURBS is a foundation truly for building resilient embedded systems. And that whatever you want to be able to do to ship your device, if you can solve these problems and make it so that that device almost feels transparent to the user, then I think that we can all create a more interesting space that we'd end up wanting to live in ourselves. Thanks.